Our first demonstration describes how the velocity of the moving object affects the force it will have. Oh, never mind. Shoot. We better be able to.
Okay, go. Okay.
Oh my God, it hurts!
Wow, look at that force! Wow, look at that lack of force! Do you see how the change in velocity affects the force?
Our second demonstration will describe how momentum is affected by the mass of the object. Go.
Oh my gosh!
Note how far the ball bounced off the wall. Amazing.
The reason the small ball didn't bounce off the wall as much as the big ball is because the change in mass. The bigger ball has a greater momentum, which means it also has a greater impulse, and bounces much farther off the wall than the small ball with the smaller mass.
Now we will use the same ball with the same mass, but at different distances, to show how distance affects force and momentum. That's some big impulse. That's not really so much.
The smaller the distance, the more force there will be because there's less time to stop. The greater the force, the greater the momentum. The more momentum, the more impulse, and the ball will bounce back farther.
Go.
Now we will review what we just learned.
Velocity and mass affect momentum directly, because the greater they are, the greater the momentum of the object will be.
However, velocity, mass, force, and time are all factors that can determine impulse.
A large impulse can be caused by a large force applied over a short time period, or a small force applied over a longer time period.
We hope this makes your understanding of momentum and impulse more clear.